First we had to note down the strain energy. What is meant by strain energy? What is strain energy? When a body is subjected to some different types of the loading, that is gradually or sudden and impact load, then the body will get some deformations due to the work done upon it. If suppose we are taking one book, we are applying some load on that book. What will happen? The book will deform downward direction. That load also in different three categories. That is gradually when we are applying 1 kg, 2 kg like that gradually applied, or suddenly we are applying the 10 kg of load. At some certain height, we are applying some load is the impact load. Based on the different loads, the deformations also will observe and the work is done upon it, upon the book. Okay. This will be within the elastic limit, and then if it is not exceeded, once we remove the load, it will again come to its original position. Then the work is stored in the body. That work done of the energy or energy stored in that body is called as the strain energy. Okay, simply I had to write the definition. Energy is stored in the body during the deformation process. Energy is stored in the body during the deformation process, and this energy is called strain energy. Okay. For this, we will observe some formulas also, and then we will solve some derivations, and then simultaneously we will go for the problems. Okay. Now I will share the notes also for you. First, please note down the definition. Strain energy is the internal energy. Strain energy is the internal energy which is stored in any material, which is stored in any material which is loaded within the elastic limit, which is stored in any material which is loaded within elastic limit. This is the definition of the strain energy. You have to write for 2 more. Next line, next point. Strain energy is also called as work done by a loaded material. Strain energy is also called as the work done by the loaded material. It is the second point. The third point is strain energy is also called as resilience. Strain energy is also called as resilience. The units of strain energy are Newton meter or Newton mm. Strain energy or resilience is equals to load into displacement. Load will be in terms of Newton or in terms of kilonewton multiplied by the displacement, that will be in meter or mm. Okay. Resilience or strain energy units are the Newton meter or Newton mm. Whatever values we are converting according to our given problem, kilonewton meter or kilonewton mm, I had to write the units for the resilience or for strain energy. Okay. Strain energy units are Newton meter or Newton mm or kilonewton meter, kilonewton mm. Depends upon the given values and then given situation. Okay. Next point, for strain energy to be stored, a material must deform within the elastic limit. Same definition only we are writing like this also. For strain energy, whatever the energy which is stored in the material must deform within the elastic limit. Next point. Same, whatever we are seeing in the definition, strain energy depends upon the applied load. That applied load will be varies into 3 types. First one is the gradually applied load, second one is suddenly applied load, and third one is impact load. I had to write the definition, whatever you had to observe in the screen, the definition is useful. Okay. Another condition is strain energy principles we had to observe in springs. Already in strength of materials lab, we observed the spring one. In that open coil and closed coil spring, whenever we are applying some load, the spring will be compressed, and then whenever we are removing the load, then automatically it will come to its original position. Similarly, here also we'll observe the strain energy principles we'll observe in the springs, then we can easily able to understand. When we apply some load, it compresses. That means the energy is stored in that spring. When the load is removed, the material regains its original position. But also, we have to observe for the spring. This is a strain energy we can observe really in our day-to-day life. Okay, the loads applied on a material can be three types. That is gradually applied load, suddenly applied load, and impact load. Depends upon the situation of that area. Okay. Again, we'll see what is meant by resonance. Resonance is nothing but it is the energy which is stored within the elastic limit. If suppose for 2 moles they will lost, what is meant by resonance means the energy which is stored within the elastic limit is called as resonance, and it is denoted by U. That is, strain energy is denoted as U. Okay. Now we'll observe the strain energy is denoted as U for a gradually applied load. For a gradually applied load, what is the formula? How we'll get the derivation for this gradually applied load? That is strain energy in an axially loaded member. I will share the screen for gradually applied load. Here you can observe we are taking a bar. For this bar, we are applying some force P. Due to this force, there will be some deformation will be observed in that bar. The length will be increased due to the pulling of the force. Then the work done is already applied for this. Work done is done here for this bar. Then we have to draw the load versus deflection diagram. That is load and deflection graph we are drawing here. For this graph, depends upon the load. If load is increased to 1, deflection is increasing to 0.1, 2, like that, we will get the straight line. The line which is passed through origin, then it will be in the form of the straight line. This is the P, this is the P force, and this is the delta L force or delta. This, whatever the area under this line is called as the strain energy. And then work done, whatever the work done is observed here due to this force, and then due to the pulling of the force, work done is done here, and then whatever the energy you had observed here, the stored energy is the strain energy. This shaded area is the strain energy, or it is also called as the complementary energy. A quantity which is utilized here in some advanced energy methods of solutions and is not considered here within the terms of the reference. Just wait, I will share my notes. I think the notes is visible for you. First, whatever the definitions you have to write here for the strain energy, and then resonance. Resonance is nothing but it is the energy which is stored in the body within the elastic limit is called as the strain energy. This equation now will derive sigma square by 2E into V. How we'll get? We'll derive this equation now. By using the derivation. This is the main derivation according to your syllabus. This is one of the methods. There are 3 derivations are there for strain energy. Strain energy in an axially loaded member. Another one is the strain energy in bending moment and in bending. And the third one is strain energy in torsion. These are the 3 derivations we have in our syllabus. First, we will observe the first derivation. This derivation will be useful for you. This derivation will get for 5 marks. Okay. First, consider All of you first draw this figure. Consider same notes. I will give you the video also. I will share you video also. First, all of you listen. All of you note down. This is a very important. Every year they are asking this question. Derive an expression for the axially loaded members for a strain energy for 5 marks. You had to derive the equation. That derive the equation is nothing but U equals to sigma square by 2E into V. This equation you have to derive here. This is the equation strain energy for the axially loaded. Okay. First consider, draw this diagram. Consider a bar of length L and a force of P is applied here, that is pulling force is applied here. For this bar, the energy, the stress which is stored in the bar, first point. First, all of you draw this diagram. For this diagram, write the first one. Stress which is stored in the bar, sigma equals to P by A. Stress formula. Stress is load by area. Stress which is stored in the bar, sigma equals to P by A. That is the first equation. Okay. Next, according to the stress diagram, now we have to draw the load versus deflection diagram. Here you can observe the load is P and the deflection is delta L. Our graph will be a straight line passing through the origin. This will be we are observing as a work done here. And then this total will be in the form of the triangular shape. You can observe here this area whatever the strain energy that will be axially applied member shape will be in the form of the triangle. Okay, area of this triangle now we have to calculate it for the calculating the strain. Strain is nothing but the change in length by original length. Again, the deflection, change in length by original length. Deflection delta L will be, you can write PL by AE according to the modulus of elasticity equation. Already in last class I told you modulus of elasticity M is equals to stress by strain. We have to divide, then we will get E equals to PL by A into delta L. This delta L will go to this side, left side means then delta L equals to PL by AE. This is our equation for deflection delta L. Okay, now all of you observe here. First is the load is P and the other side is on the right side, on the bottom we are getting here deflection delta L. Now we'll write the area of this triangle. Area of this triangle is half into P load into delta L. This one is the delta L. Now we'll substitute the values. P is nothing but according to the first equation, P equals to sigma into A. Now we'll write in terms of P sigma A and delta L will be sigma L by this one I will write as sigma. P by A as sigma into L by E. You can observe here. Sigma L by E. Okay, half into P is sigma A, delta L is sigma L by E. Okay, now I will write this total area of this axially loaded member. Area of the axially loaded member A equals to half into sigma A into sigma L by E. Then that A equals to sigma square, sigma into sigma is sigma square. Area into length is volume. We'll get the volume sigma square V by 2E. This is the second equation. First equation is stress which is observed in the bar. Second equation is the area of the bar that you had to observe for the strain energy. A equals to sigma square V by 2E. It is the strain energy. Strain energy is again by seeing the equation from 1 and 2. We'll write the strain energy U equals to this here, whatever the area that you had to observe here is the strain energy. This one is the strain energy, whatever the shaded line is there, this strain energy, this strain energy U equals to this total area of this curve, okay, or area of that graph. Now we'll write that strain energy U equals to sigma square V by 2E. This is a derivation we had to derive. For this derivation, they will give you 5 more. Okay, this is the strain energy for the axially loaded. Okay, but next, proof resilience. What is resilience or strain energy equation is? U equals to sigma square V by 2A. This is the main formula. This is the main formula for the axially loaded. This is the main formula for the strain energy. Or again, it is called as the resilience also. Next one is the proof resilience. Proof resilience is nothing but the maximum energy which is stored in a material. If suppose we are applying, starting is the resilience is nothing but the energy which is stored in the elastic limit is called as the strain energy. Proof resilience is nothing but the maximum strain energy which is stored in a material is called as the proof resilience. That proof resilience is again we had to write as U maximum. U is the strain energy or resilience. U maximum equals to sigma square maximum into V by 2E. This is the proof resilience formula. For 2 marks they will ask what is meant by proof resilience, or otherwise they will ask differentiate between the resilience and proof resilience. Resilience is U equals to sigma V by 2E, sigma square V by 2E. Proof resilience is U maximum that equals to sigma square maximum V by 2E. This is the second formula. Okay, note down one by one. Then I will simultaneously I will give you the notes also. You have to check the notes and then you have to prepare. Next week also you have the same online classes now. That's why we had to complete this first unit within 2 weeks. Next we'll see some problems also. It is very easy, first unit. Next one we will observe the modulus of resilience. What is meant by modulus of resilience? Modulus of resilience is nothing but the ratio of the strain energy per unit volume. Modulus of resilience is defined as the strain energy. The ratio of the strain energy per unit volume is called as the modulus of resilience. And then we will write here modulus of resilience as M equals to sigma square by 2E into V. This is our strain energy divided by the again volume. Volume will get cancelled here. Then modulus of resilience formula is sigma square by 2E. Modulus of resilience equals to sigma square by 2E. These are the 3 definitions, very important. First one is the what is meant by resilience. Second one is what is meant by proof resilience. Third one is modulus of resilience. First, resilience is nothing but the energy which is stored in a body within the elastic limit due to some work done. For that, you have to calculate for a gradually applied load U equals to sigma square V by 2E. This is the first formula for strain energy or resilience. Next one is the proof resilience. Proof resilience is nothing but the maximum energy which is stored in the body is called as the proof resilience. That also within the elastic limit. The maximum energy which is stored in your body within the elastic limit. That is U maximum. U maximum equals to sigma square maximum into V by 2 into E. E is nothing but the modulus of elasticity. That will be changes for the different material. If suppose modulus of elasticity for a steel is 2 into 10 power 5 Newton per mm square. This already we derived in strength of material slab. Okay, most probably you have to take that E value. E equals to 2 into 10 power 5 Newton per mm square only. Next one is modulus of resilience. This modulus of resilience is again defined as the strain, the ratio of the strain energy per unit volume. Strain energy per unit volume is first you have to write the strain energy formula by 2E into V by again V. Then VV will get cancelled. Then this is the main definition for today class. Again, I will show you what are the different types of the loads that has to be observed here. The stresses in the members for different loads. Okay. Now here observed here the stresses in members for different cases. There is 3 cases already we've seen according to our definition of the strain energy. First one is the gradually applied load. Here you can observe, all of you observe here. The gradually applied load, the diagram is this one. Left side, according to your side, right side diagram is there. For a gradually applied load, load is applying 1, 2, 3, 4 like that kgs, and the deflection will be changes to 0.1, 0.2 like this. The diagram for the gradually applied load, the stress is given by sigma equals to P by A. The stress is given by P by A. Whatever the stress load applied depends upon the particular area. Our gradually applied load stress is P by A. If suppose we are applying a sudden load means instead of 1 kilonewton, I am applying the 10 kilonewton or 2 kilonewton. Then my formula is for a suddenly applied load, the stress is given by, I have to observe this diagram. The P is changes to double 2 times, 2P by A. Stress per gradually applied load is P by A. Stress per suddenly applied load is 2P by A. That is, the whatever the load you are applying will be the 2 times. If you are applying 10 times also, the formula is 2P by A only. Okay. Similarly, impact load. Impact load means already we told at certain height we are applying some load. Suddenly, that is called as the impact load. Okay, here you can observe this one. We are applying some the load for a collar. Then at certain height we are releasing the load. Then suddenly it will fall on that collar. The sudden load will be observed here. For that, the stress is given as sigma equals to P by A plus square root of P by A whole square plus 2E T into H by A square. T is nothing but always the load only. Whatever the load that has to be observed. H is the height of the height from collar to the starting point, and A is the area of that particular collar. E is nothing but the modulus of elasticity. This is the impact load. But for our condition, for our syllabus, structural analysis 1, strain energy method, here we have only the gradually applied load only. You have to consider only this case only. For MTech level, you can go for the impact load and then suddenly applied load. Okay, here we will consider only the stress in gradually applied load, that is P by A only. Now we will observe some problems now. Okay, Harini, LE1, note చేసుకుంటున్నారమ్మా notes?
Yes, ma'am.
ఈ ప్రాబ్లం నోట్ చేసుకోండి, చాలా సింపుల్ ప్రాబ్లమ్స్. మీకు యాక్చువల్గా ప్రీవియస్ క్వశ్చన్ పేపర్లో 5 మార్క్స్ అడుగుతారు. స్ట్రెయిన్ ఎనర్జీ గురించి నోట్ చేసుకోండి అందరూ. A steel bar of 50 mm into 50 mm in section 2. That is, here they gave the different section. One is the length wise, another one is the width wise. A steel bar of 50 mm into 50 mm in section 2, 3 meters in length. 3 meters in length is subjected to an axial pull. 3 meters in length is subjected to an axial pull of 140 kilonewton. Calculate strain energy. Calculate the strain energy stored in the bar. Strain energy stored in the bar ante U calculate cheyala. U equals to మన formula ante sigma square into V by 2E. That is our formula. That is the first you have to calculate it, first one. And also find extension of the bar. Extension of the bar is nothing but the change in length. Delta L you have to calculate here. Extension of the bar, and also find the extension of the bar. Take E equals to 200 gigapascals. Okay, that is the question. First all of you note down the question clearly and then write the given data as per the question. Write the given data. Here they are not at all telling us there is a suddenly applied load, and then they are not at all telling it is at a certain height the load is falling. So we have to take this load as this type of the load we are taking as a gradually applied load. Okay, that's why gradually applied load, the load is 140 kilonewton load, first one. Okay, next, given data, length of the bar they are given as 3 meters. That 3 meters we are converting into mm. Length of the bar is 3 meters they gave. That length is, that bar is in a shape of square shape. The area of the bar is L into B, that is 50 mm into 50 mm. Steel bar of square shape, 50 into 50 mm, and the length is 3 meters. Okay, if you observe a stick is 3 meters, the shape of the stick is square shape, 50 meters into 50 meters, 50 mm into 50 mm. Okay, Now we have to write the given data. L equals to 3 meters, that you have to convert into mm, 3000 mm. 1 meter equals to 1000 mm. Next one is the force, axial load, that is axial pull of 140 kilonewton, that you have to write. The P equals to 140 kilonewton here. That kilonewton also had to convert into newton, 140 into 10 cube newton. Next one. E, here they gave E value. E is nothing but the modulus of elasticity. Or modulus of rigidity, whatever it may be. E equals to 200 gigapascals. 200 into giga is 10 power 9. Pascals is 10 power minus 6. Then we'll get here 200 into 10 cube Newton per mm square. That value will be 2 into 10 power 5 Newton per mm square. E equals to 2 into 10 power 5 Newton per mm square. Okay, this is a given data. Now, our solution. First, for a gradually applied load, our equation, stress, strain energy stored in the bar. Write the equation, strain energy stored in the bar. For that, first you have to calculate the stress value, sigma we want. How to calculate the sigma? Stress equals to stress for a gradually applied load, P by A. Okay, good. P is 140 into 10 cube by
50
by area is how much? 50 into 50. Entama? Sigma into chini?
56 Newton per mm square.
Okay. P is 56 Newton per mm square. Okay. Next one. Strain energy. Strain energy U equals to sigma square by 2E into V. Simple formula, okay, formula substitute చేసేదే. Sigma already మనం calculate చేసాము 56 అనేసి. 56 into 56 by 2 into 10 power 5 into 2 into volume ante. What is meant by volume here? Area into?
Length, ma'am.
Area already 50 into 50 ఇచ్చారు. Length ఎంత?
3000 mm.
Okay, ma, good. Substitute value and then tell me the value of strain energy. U equals to how much? U equals to ఎంత వచ్చిందా? 56 square by 2 into 10 power 5 into 3000 into 50 into 50. What is the strain energy? U 144. Shravani చేస్తున్నారా ప్రాబ్లం? ఎంత వచ్చింది మా U? $58.8 వచ్చిందమ్మా. అపర్ణ U equals to 58.8. హరిణి వచ్చిందమ్మా. స్ట్రెయిన్ ఎనర్జీ U equals to మీకు ఎంత వాల్యూ వచ్చిందో చెప్పండి. పూజశ్రీ ఎంత వచ్చింది మా వాల్యూ? హలో
58,800
యూనిట్స్. స్ట్రెయిన్ ఎనర్జీ
Newton per mm square.
న్యూటన్ పర్ కర్మ, న్యూటన్ డాష్. ఎందుకంటే లోడ్ ఇంటూ డిస్ప్లేస్మెంట్ కదా, న్యూటన్ ఇంటూ ఎంఎం. ఓకేనా? నెక్స్ట్ వన్, ఫస్ట్ కండిషన్ మీరు క్యాల్కులేట్ చేస్తారు స్ట్రెయిన్ ఎనర్జీ. సెకండ్ ఏం క్యాల్కులేట్ చేయాలి? ఎక్స్టెన్షన్ ద బాల్ ఎంటైర్లీ. Calculate extension of bar using the formula delta L equals to sigma L by E. అంతేనా ఫార్ములా?
ఎస్ మేడం.
క్యాల్కులేట్ చేస్తాను.
0.84 వచ్చింది మేడం.
ఓకే, గుడ్. 0.84 యూనిట్
mm.
Okay, let's note down the second question. The question చేసేసేయండి ఇప్పుడే నేను. Okay. See here. Okay, please note down the second question. A steel bar of 4 centimeter into 4 centimeters in section. Three centimeters long, full of 128 kilonewtons. E equals to 200 giganewton per mm square, giganewton per meter square. Calculate alteration in length of the bar. Calculate alteration in length of the bar. Calculate also the amount of energy stored in the bar. కనిపిస్తుంది మా క్వశ్చన్ నోట్ చేసుకొని బ్యాలెన్స్ చేసి చూపించండి. Please note down the question. Ramesh na చేసి చెప్పండి మా ఆన్సర్ చెప్పండి.
Yes, madam.
మోస్ట్లీ సింపుల్ ప్రాబ్లమ్స్ వచ్చేసరికి 5 మార్క్స్ అని అడగచ్చు. యాక్చువల్గా మన సిలబస్ ప్రకారం వచ్చేసరికి స్ట్రెయిన్ ఎనర్జీ డ్యూ టు యాక్సియల్ లోడ్ అండ్ దెన్ డ్యూ టు ఇన్ బెండింగ్ అండ్ దెన్ డ్యూ టు టార్షన్ యూ హ్యాడ్ అబ్జర్వ్. ఇవి ఓన్లీ చిన్న ప్రాబ్లమ్స్. మీరు ఓకే క్లాస్లో ఫస్ట్ 2 ప్రాబ్లమ్స్ చేసేస్తే చాలు. చూడండి సేమ్ ఆన్సర్ వచ్చిందా. ఫస్ట్ యూ హ్యావ్ టు ఫైండ్ ద చేంజ్ ఇన్ లెంత్, దట్ ఈస్ ద
Madam, change in length వచ్చేసి 1.2 mm madam.
ఎంతమా?
1.2 mm madam.
1.2 mm. ఓకే. స్ట్రెయిన్ ఎనర్జీ వచ్చేసరికి 76.8 న్యూటన్ మీటర్. ఆ న్యూటన్ మీటర్ ని మనం ఆల్సో కాల్ as J.
Joules.
J అంటే ఏంటి?
Joules madam.
కరెక్టే. జౌల్స్ కరెక్టే. అదే జౌల్స్. J also will call as the strain energy will be in terms of joules also. So this is the another problem I had to observe. ఇవన్నీ సింపుల్ ప్రాబ్లమ్స్ మీకు యాక్చువల్గా దీంట్లో చేస్తుంటారు. ఓకే, నెక్స్ట్ నోట్ డౌన్ ద థర్డ్ వన్, వెరీ ఈజీ వన్. A mild steel plate is 400 mm long, 200 mm wide and 50 mm thick. a mild steel plate is 400 mm long, 200 mm wide, and 50 mm thick, is subjected to gradually applied load of 1200 kilonewton. Calculate first one proof resistance, second one modulus of resistance, and the third one is elongation. Elongation, you have to calculate the 3, and the E value is 200 into 10 power 3 megapascals. This is the question, very simple question. All data are the given data only. First point the given data, that is the load is gradually applied load. Here already in the question they gave us the load is subjected to gradually applied load. And the length of the beam is, or length of the bar is 400 mm. Force P is 1200 kilonewton. And the bar size is 200 mm width, 50 mm thick. Area of the bar is 200 into 50. Okay. Next, first one is we have to calculate as proof resistance. What is proof resistance? Proof resistance is nothing but the maximum energy that is stored in the body. For proof resistance, first we have to calculate the sigma. Sigma is P by A. First we have to calculate the sigma P by A, that is 1200 into 10 cubed by area of the bar is 200 into 50. That is 120 Newton per mm square. Proof resistance is U equals to sigma square by 2E into B. Here, whatever the value given for the gradually applied load is the maximum value only. That's why proof resistance is maximum value, that is sigma square by 2E into B. Sigma is already calculated as 120 square by 2 into 10 power 5 into B is area into length. Area is 200 into 50, length is 400. All are in mm under Newton per mm square. E also here, E value మీరు ఒకటే గుర్తుపెట్టుకోవాలమా, మీకు ఇది కన్వర్షన్స్ రాకపోతే డైరెక్ట్ గా 2 into 10 power 5 అనేయండి. లేదు మాకు తెలుసు మేడం అంటే మెగా అంటే ఇంటూ 10 power 6 బై మెగా పాస్కల్ అంటే అగైన్ మళ్ళీ 10 power minus 6 వస్తుంది. 10 power 6 into 10 power minus 6 రెండు క్యాన్సిల్ అవుతాయి కాబట్టి 2 into 10 power 5 న్యూటన్ పర్ mm స్క్వేర్ అని వస్తుంది. మీకు అదంతా మాకు తెలియదు మేడం కన్వర్షన్ అంటే E ఈక్వల్స్ టు 2 into 10 power 5 న్యూటన్ పర్ mm స్క్వేర్ అని రాసేసండి. మాకు తెలుసు కన్వర్షన్ అంటే కన్వర్షన్ చేసేసి రాయండి. దెన్ ప్రూఫ్ రెసిస్టెన్స్ వాల్యూ వచ్చేసరికి మనకి 144 న్యూటన్ పర్ మీటర్ వచ్చింది. న్యూటన్ డాష్ మీటర్ నాట్ పర్ మీటర్. ఎందుకు అంటే సిగ్మా అంటే ఏంటి, స్ట్రెస్ అంటే ఏంటి, న్యూటన్ పర్ mm స్క్వేర్ ఇంటూ అగైన్ mm క్యూబ్ అవుతుంది మనకు వాల్యూమ్ అంటే. mm స్క్వేర్ mm క్యూబ్ లో నుంచి క్యాన్సిల్ అయితే న్యూటన్ ఇంటూ న్యూటన్ డాష్, ఇక్కడ నాట్ ఏ పర్, న్యూటన్ డాష్ mm. దిస్ వన్ న్యూటన్ డాష్ mm, ఇట్ ఈస్ జౌల్. ఓకే, ప్రూఫ్ రెసిస్టెన్స్ ఇస్ 144 న్యూటన్ మీటర్. Next, modulus of resonance. One formula is the modulus of resonance is the ratio of strain energy per unit volume. Strain energy ante ikkada vacha 144 divided by unit volume veste you will get this one, or otherwise directly you will write sigma square by 2 into E. Okay, next modulus of resonance value is sigma square is nothing but than Newton per mm square. 2 times వస్తుంది by Newton per mm square. whatever రెండు గెట్ క్యాన్సిల్ అయితే Newton per mm square వచ్చేసి modulus of resonance వస్తుంది. Next, deflection. Delta L equals to sigma L by E. This is the formula for deflection. Deflection sigma అంటే ఆల్రెడీ మనకి మాక్సిమం స్ట్రెస్ ఇచ్చారు కాబట్టి 120 into length of the bar వచ్చేసరికి 400 mm by E is 2 into 10 power 5. Deflection of the bar is 0.24 mm.
మ్యామ్ స్క్రీన్ కనబడడం లేదు మ్యామ్.
స్క్రీన్ కనపట్లేదా?
ఎస్ మ్యామ్.
ఓకే, మీరు సాల్వ్ చేయండి మా. మీకు అర్థమైంది కదా? నేను ఒకసారి మళ్ళీ స్క్రీన్ షేర్ చేస్తాను. ఈలోపు సాల్వ్ చేస్తా ఉండండి. ఎక్కడి వరకు ఆగిపోయారు చెప్పండి. ఎక్కడి వరకు చేశారు?
మోడలస్ ఆఫ్ రెసిలియన్స్ వరకు.
మోడలస్ ఆఫ్ రెసిలియన్స్ ఫార్ములా సిగ్మా స్క్వేర్ బై 2e. మోడలస్ ఆఫ్ రెసిలియన్స్ ఈక్వల్స్ టు సిగ్మా స్క్వేర్ బై 2e ఫార్ములా వేయండి ఫస్ట్. అందులో సబ్స్టిట్యూట్ చేయండి. ఇది నెట్ కనెక్షన్ పోయింది, అందుకనేసి పోయింది ఇది. సిగ్మా స్క్వేర్, సిగ్మా అంటే ఆల్రెడీ మనకు తెలిసిన వాల్యూవే. సిగ్మా ఎంత వచ్చింది మనకి? 120 వచ్చింది. 120 స్క్వేర్ బై 2 into E is 2 into 10 power 5. Modulus of resonance is sigma square by 2e. Next, deflection. Deflection is delta L equals to sigma L by E. Sigma is already we know 120 into L is length of the bar 400 by E is 2 into 10 power 5. Okay, ఈ చిన్న ప్రాబ్లమ్స్ మామూలుగా 5 మార్క్స్ అడుగుతున్నాం. ఇది వచ్చేసరికి సేమ్ గ్రాడ్యువల్లీ అప్లైడ్ లోడ్ ఫార్ములా ప్రాబ్లమ్స్. Then today class we solve the 3 problems. First one is normal whatever the given bar, for that bar we had to calculate the strain energy U. U equals to sigma square V by 2E. Next, extension of the bar or change in the length adigaru calculate chesam. Second kuda same question but values are changes. And the third question is they ask us to calculate the proof resonance, modulus of resonance and then deflection. This is the 3 problems for the gradually applied load. Okay. Next, we will see only one problem for impact load. ఇది ఒక ప్రాబ్లం నోట్ చేసుకోండి ఈరోజు క్లాస్కి. అగైన్ నేను ఇప్పుడు చెప్పిన ఈ ప్రాబ్లమ్స్ అన్ని యాక్చువల్గా క్లాస్లో చెప్పి రికార్డ్ చేశాను. అది మీకు పంపిస్తాను నోట్స్. క్లాస్లో మీకు బోర్డ్ పైన ఎక్స్ప్లెయిన్ చేసిన నోట్స్ పంపిస్తాను. ఓన్లీ 2-3 ప్రాబ్లమ్స్. నెక్స్ట్ ట్యూస్డే క్లాస్కి వచ్చేసరికి నేను డిరైవ్ చేసేసి 3 డెరివేషన్స్ ఉన్నాయని చెప్పాను కదా మనకి సిలబస్లో. ఒకటి వచ్చేసరికి మోడలస్ ఆఫ్ అదే యాక్చువల్లీ లోడెడ్ ఆల్రెడీ మనం సాల్వ్ చేసిన U ఈక్వల్స్ టు సిగ్మా స్క్వేర్ V by 2E ఫస్ట్ ఈక్వేషన్. నెక్స్ట్ మోడలస్ బెండింగ్ మూమెంట్, బెండింగ్ ఇది ఒకటి వస్తుంది, టార్షన్ వస్తుంది. ఆ 3 సాల్వ్ చేసి మీకు మళ్ళీ నేను వీడియో పెడతాను. ఈ రోజు క్లాస్కి ఇది ఒక ప్రాబ్లం నోట్ చేసుకోండి. ఓకే, నోట్ డౌన్ ద నెక్స్ట్ వన్. డిటర్మైన్ మా స్క్రీన్ కనిపిస్తుందా?
Yes, madam.
ఓకే మా, ఈ ప్రాబ్లం నోట్ చేసుకోండి, ఇది ఒక ప్రాబ్లం. డిటర్మైన్ ద ఇన్స్టాంటేనియస్ stress and deformation. Instantaneous stress and deformation of a rod of length 1 meter. Determine the instantaneous stress and deformation of a rod of length 1 meter and diameter is 6 mm. Length is 1 meter, diameter is 6 mm. Is the mass of 50 kg. Here you can observe this diagram. Is the mass of 50 kg falls through a height of 10 centimeters. Falls through a height of 10 centimeters and strikes the bottom of the rod. That is an impact load, sudden load. Not a sudden load, at the height ichcharu kabatti impact load ani manaku ikkada clear ga telustundi. Falls through a height of 10 centimeters and strikes the bottom of the rod. The rod is freely suspended and fixed at the top. You already strength of materials lo chesintaru impact load anesi at certain height nunchi chart piece impact అని చేసింటారు, chart piece చేసింటారు, impact చేసింటారు. then దాని బేస్ చేసుకొని ఈ ప్రాబ్లం. ఓకే, బట్ ఇక్కడ ఏమంటే స్ట్రెయిన్ ఎనర్జీ క్యాల్కులేట్ చేస్తాం. యువర్ ఇన్స్టాంటేనియస్ స్ట్రెస్ ఎలా వస్తుంది, డిఫార్మేషన్ ఎలా ఉంటుంది అనేది క్యాల్కులేట్ చేస్తాం. ఓకే, ద రాడ్ ఈస్ ఫ్రీలీ సస్పెండెడ్ అండ్ ఫిక్స్డ్ అట్ ద టాప్. అజ్యూమ్ E equals to 210 gigapascals. 210 gigapascals. That is E is 2.1 into 10 power 5 Newton per mm square. First, all of you please note down the question. Then write the given data. If you want clearly, you have to know means you have to draw the diagram. And otherwise, no need to draw the diagram. Directly you can go for the problem. First, write the given data. The type of the load is impact load here. What you have to calculate is instantaneous stress. That is the maximum stress that has to be obtained here. And then you have to calculate the change in length. That is the deformation also you have to calculate here. First, write the given data. The length of the bar is 1 meter. That 1 meter had to convert into mm, 1000 mm. Diameter of the bar is, they gave us 6 mm. Next, area of the bar, it is in the form of radius. Diameter ichcharu kabatti circular form lo undi. Circular form lo unnappudu radius of the circle is 5d squared by 4. సర్కులర్ ఎందుకు మనకి ఇది సర్కులర్ అని అనుకుంటున్నాం అంటే ఇక్కడ డయామీటర్ అని ఇచ్చాడు కాబట్టి, డయామీటర్ ఆఫ్ ద బార్ అని ఇచ్చాడు కాబట్టి సర్కులర్ షేప్ అనుకొని ఏరియా ఆఫ్ ద సర్కిల్ క్యాల్కులేట్ చేస్తాం. ఏరియా ఆఫ్ సర్కిల్ ఇస్ 5d square by 4. Then we can get the area of the bar 28.27 mm square. Then mass at certain height, ఆ బార్ యొక్క వెయిట్ ఎంత ఉంది అంటే 50 kg ఉంది. అది that will be 50 kg that will convert into newton. 1 kg equals to how many newtons? 9. ఎంతమా 1 kg equals to
9.81.
9.81 newtons. Okay, 50 into 9.81 చేస్తే then you will get 490.5 newtons. Actually 50 into 10 అని వేసుకోవచ్చు, బట్ పక్కగా ఉండాలి అంటే 9.8 వేసుకోవచ్చు. Mass of the body is 50 kg, that will converted into newtons, 490.5 newtons. Then height is 10 centimeters they give, that centimeter had to convert into mm. That is 100 mm. Let's calculate the first one. According to our diagram, First we have to convert, we have to write the all given data. L is 1 meter, 1000 mm. D is 6 mm. Then we calculate the area of that bar, pi d square by 4. Then we have to convert the mass into Newton. Weight, that is mass is 50 kg, and then weight is 490.5 Newton. H is 10 centimeters. That centimeter also we can convert to the mm, 100 mm. Now we will go for the problem. For impact load, our formula is sigma maximum equals to W by A plus square root of, actually our formula is P by A plus square root of P by A whole square plus 2E P into H by A into L. But here we all converted, that's why we are writing as W by A plus square root of W by A whole square plus 2E into WH by A square. Had to write, and then you had to find the instantaneous stress in the given diagram. That instantaneous stress అనేది మనం అన్ని values substitute చేస్తే then you will get the sigma maximum is 871.0 Newton per mm square. Stress value, instantaneous stress is 871. Another one is delta maximum equals to sigma maximum into L by E. That is the formula. Change in length delta L equals to sigma L by E. This one is the impact load formula. Impact load problem. Very simple problem. According to the given load, given data, we have to write in our formulas, and then we can substitute easily. This is the one method. Emma, complete అయినా? These are all the problems. For actually, you had to solve this all type of problems in STEM. So here, no need of this type of problems. Next class, we will go for directly the derivation. I will explain clearly the derivations of strain energy due to bending, and then Castagne's theorem also. We'll see these all derivations in the next class. Okay, ma? If I have any doubts, ask me. Okay, students. Thank you, ma. First, listen, all of you.